Good afternoon. Thank you for opening the bar before I start. My talk today is on a project that my colleague Kent Eisenhuth, who used to work with me at a company called Infragistics, who has now moved to Google. This was not a joint partnership. And I'm talking today about redesigning the software that controls atomic force microscopes. A company called Keysight, one of the leading manufacturers of test measurement software, called us and asked us if we could help them redesign this software on this very expensive equipment. It essentially measures and takes pictures of really small stuff like red blood cells, or even the bonds between atoms. What these machines can do is really, really cool, but using them is a nightmare. The software was originally designed by PhD physicists for use by PhD physicists. And when they designed it, it was used by the people who designed it and maybe a couple of other professors, and that was it. And the learning curve to become proficient at using this is incredibly steep. It takes years to master. And part of the problem is that you'll notice that all of the functionality is presented to all of the users all of the time. And on top of that, it was designed around the standard Microsoft Windows multi-window design paradigm, which means in order to do any single task, it meant opening up lots of windows. Originally, the machine didn't come with a display, so people would set up 2 monitors and spread out stuff across 2 monitors. Stuff was buried behind things. It was impossible. And just to give you some sense, new novice users, think grad students, had a 0 success rate, 0%. No novice user could use this device ever. So this presented a problem because Keysight was interested in solving a number of problems, only one of which was trying to decrease the amount of time it takes to train new users. They also wanted new scientists, both in academia and outside of academia, to be able to focus on science instead of fighting the software. That goes hand in hand with the third bullet, which is they wanted to sell this thing outside of academia. They wanted to introduce this to a whole new set of users, in part for monetary reasons. Universities can only buy these things once every 5 years or so when they get new grants. They cost anywhere from $250,000 to $500,000, so people just don't own one of these for themselves. But in order to sell these, they had to be usable by a very different class of users in industry than somebody who's been a physics professor all their lives. We did what you would expect. We went out and conducted a couple of weeks of contextual inquiries across these different classes of users. There were standard expert users, so we spent time in university labs talking to physics professors. There were, think of it as part-time users, biologists, chemists. These folks might not own their own machine, but might use time from somebody else's machine. There were obviously grad students, lab technicians, and then the production team itself, people who maintain these devices. Once we understood kind of the mechanics of how you use this, had some sense of the user workflows, their mental models, and had some notion of the physical environment. You'll notice here that this professor is twiddling knobs on the actual device, watching the results of those changes reflected in the software from like 6 to 8 feet away. We began to get some notion of how the design might need to take shape, because people would need to use it while sitting at the desk as well as from across the room. And with the new machine, because you're spending $500,000, it comes with a 32-inch monitor. Not surprisingly, one of the things we found out was that new novice users tend to need most of the help following a very linear, basic path through the application in order to take a decent picture of something really small. Experts, on the other hand, tend to jump around. They work non-linearly. You know, they'll do something here, they'll go back a couple of steps, make a change to a parameter, jump forward 3. In order to accommodate that, we did a number of things. The first thing we did was we embedded some training in the layout of the global navigation itself. You'll notice across the top here, load, prepare, approach, measure. Those are the 4 main steps to taking a good picture of something really small. And you start from the left and you work to the right. Second, we allowed users to step through this sequentially by using left-right arrows on both sides of this stack of cards. And third, we use this cards metaphor for a couple of reasons. The first is a stack of cards implies a sequential process. That gave new users a bit more confidence, not only that they were on the right track, but they knew in general how far along in the process they were. We also used the card metaphor to separate basic versus advanced functionality, and I'll show you that in a minute. None of this, however, prevents the experienced users from jumping back and forth the way they would ordinarily. All we have done here is remove from view, unless you request it, that advanced functionality. Once we felt we had a handle on that stuff, we were able to create some wireframes. We put together an interactive prototype. My company sells its own interactive prototyping tool, not commercial. But what we were able to do with our prototype then was go back out to the folks that we had spoken to earlier and conduct 2 rounds of validation, one with the wireframes in the interactive prototype, the next round with the comps in the interactive prototype, to make sure that the things we thought would make sense actually did make sense. And to do this, we actually did a separate round where we printed these things out in 1-to-1, which meant a trip to Staples to get a piece of paper this big. And that was a lot of fun, too. All right. The end result looked like this. I don't want to spend a lot of time talking about this specific screen, but it was designed to lay out recent experiments and experimental templates. There's more detail in this than we have time for. But what I would like to do is use this to show you just a little glimpse. Let me move this over. To give you some sense of how that card metaphor works in action, right? So I select, here's the experiment I would like to pull up. Come on, baby. No, still in front of me. Hang on. There we go. Oh. Yeah, you're not going to be able to see that. Okay. Yeah, this is Microsoft. Maybe it's not. I'll just blame them because it's easy. I haven't heard anybody from Microsoft here tonight, so. In any event, let me show you then that card metaphor in action when we separate basic versus advanced functionality. You'll notice big pictures on the right-hand side, detailed settings on the left-hand side. This is a basic view, so I don't have much showing there, because in order to take a basic picture of whatever this little thing is, I don't need to do a lot. But if I do, we use that metaphor for cards, similar to the way, I forget who it was earlier this morning, was talking about the football cards. We were thinking baseball, but that's just us, where you're looking at basic set of information on the front, but if you want to see detailed information, you flip it over. Similar to the way that if you're familiar with any sort of search functionality, basic search is easy enough. I just fill in the input field. If I want advanced search, I find the thing that says advanced search, and then suddenly my screen displays a whole lot more options. So what we did was we flipped the card if I click on the icon to show me the advanced information, so that when I'm done, now I have more details here. It was a nice metaphor to walk all the way through. Ultimately, what we did was demonstrate the value of a design process to a very traditionally non-design audience. Not only did we actually eliminate the need for novice training, we took that from 0% to 100%. But our design enables scientists now to focus on science rather than software. And that holds true not only for the traditional academics, but for the non-traditional industry users of this. Think like Dell or somebody who's looking at disks coming by in a line, checking for imperfections. And then finally, we were able to introduce new functionality that Keysight had wanted to include but didn't know how into the existing application in such a way that it made it available, it made it intuitive, but it didn't make it more difficult for people to use the application. Thank you. I do have time for questions. Somebody must want to ask me a question about this picture. Why does the text look so small, but the images look so big? It's because if I'm looking at the images, I'm probably standing across the room, and if I'm fiddling with input fields on the text, I'm probably sitting at the desk. Yes?
You shared some of the results, and it sounds like it has across those metrics. Did you get to talk to any of the scientists who got to use the new product?
Yes, they loved it. No, they did, and I say that not just from anecdotal evidence, but there are university labs that have both this atomic force microscope, but also have electron microscopes also sold by Keysight. And we did not initially have anything to do with that software, so it looked basically like the AFM software. And their customers for the electron microscope complained back to Keysight that their colleagues had much better software than they did, and when were they going to get the good stuff too? So we just finished a project to redesign the electron microscope software as well. So I'm counting that as a win. Other questions? Anybody? No? Alcohol? Right on. Thank you very much.